You thought your ear was cool? Whoa. Let's talk about the eyeball. The first, by far, coolest fact about the eyeball that you have to know is that your eye is actually brain tissue. What? When you were just a little guy in your mama's belly, your brain, your neural tube, your diencephalon made these two little feelers, these two little antennas that pooched out of your neural tube and then came around to the front of your face. And now you have brain tissue on the front of your face. Now you can't see my brain tissue. Now you can. Bye-bye. My brain is back. Oh my gosh, isn't that cool? In fact, this outer layer of eyeball, it's called the fibrous tunic. Our eye has 3 layers that we can organize all the structures, all the anatomical structures are organized into 3 layers, and the outermost layer is called the fibrous tunic. Fibrous tunic, fibrous layer, that says tunic, right? It is an extension of dura mater. Really? That's awesome. So let's look at that fibrous tunic first. There are 2 primary structures that we're going to know. The first is the white part of an eyeball, and it's called the sclera. And the second is a clear part of an eyeball, and that is called the cornea. Both of them are thick, fibrous protective structures. We also have a vascular tunic. So the vascular tunic is deep to the fibrous tunic. And the vascular tunic has a same general setup as the fibrous tunic. We have a posterior portion, sclera with fibrous tunic, and anterior portion, cornea. Same similar setup with the vascular tunic. The posterior part of the vascular tunic, which is right here, it looks polka dotty because it's actually giving you a little hint about what's in there. There's a whole bunch of blood vessels in there. It's a very vascular structure, and it's called the choroid. Choroid. That is not a G. That looks like it says ghostioid. Choroid. The choroid is responsible for providing a blood supply for the retina, and that's the neural part of the eye, and we'll talk about that in just a second. So choroid is posterior. Anterior to, or the anterior aspect of the vascular tunic has 2 main parts, and they would be the ciliary body. Ciliary body, and that's this thing right here. Now, the ciliary body is a piece that's actually connected to these little ligaments. They're called suspensory ligaments that hold on to what? What is this thing right here? That's the lens of your eye. And so if you look at this, you actually have these little suspensory ligaments holding the lens in place. Now, you probably noticed that when you look far away, you can feel your eye adjusting to look at something far away and then come back and focus on something up close. And what's actually happening is that your suspensory ligaments are attached to muscles in the ciliary body that contract or relax and change the shape of the lens. As the lens changes its shape, it's going to keep the light waves focused on your retina so you can actually perceive a vision in focus. You can perceive sight in focus. When your lens stops being able to, like, adjust between here and here or here, right there, my lens can't adjust anymore to this close. Oh, you can't even see where it is. How's that? I can't see this. I mean, I can see it, and I probably can do fine. I can read it, but it's not in focus anymore. Back in the day, it was totally in focus. Like, I could put my face like this, and I could totally read it all in focus, right? Because my lens was super young and flexible. And now my lens says, You have abused me long enough, and I'm starting to get rigid, and I can't change, which means that you have to get some reading glasses. Really? Am I at that point in my life? I guess so. This was my vascular tunic. What else? The vascular tunic also includes the iris, and the iris is the colored part of your eye. The iris surrounds a hole, a pupil. This is the pupil, and it actually is a hole because if you didn't have a hole in your eye, if you didn't have a little window that light could go in, you aren't going to be able to see anything. So let's make sure we have a hole there, and that is your iris. And we've already talked about the muscles that are involved, that are found in there, that are controlled by parasympathetic and sympathetic neurons that control the size of your pupil. And so those are found like embedded in the iris. This guy, this thing is actually a little border. Whoa, really? Let's try this color. It's like this little, it's called the ora serrata. Serrated edge, like serratus anterior. And the ora serrata separates, look, the neural tunic. The neural tunic is right here. It's the innermost layer, neural tunic. It's got one primary structure, and it's a posterior structure. Do you see how this structure actually like ends right here? At the line of ora serrata. So where you see ora serrata, you know that, oh, my neural tunic is going to start back there. And the neural tunic, that's where the magic happens, my friends, because that's where the retina is. The neural tunic contains the retina. And the retina, holy complication. Yeah, there's actually, I'm coloring the retina because, you know, you got to have some color. Oh, so pretty. The retina has, I don't know, 5, 6 layers of cells. There is an outrageous amount of communication between those layers of cells. And the mechanics of how the light sensitive cells, which are rods and cones embedded in the retina, the rods and cones react to light, but all those other layers control and modify what information is actually going to be sent from the original stimulus to the brain. And it makes you like, oh, it's so fantastic. How's the message going to get to the brain? All of my little neural, not all of them, some, I'm now coloring it in blue because that makes perfect sense too, doesn't it? So some of my neurons in the retina, some of those cells are going to synapse on neurons whose axons are going to travel through this giant optic nerve. And the optic nerve, you can grab it, you can see it. It actually, all of them, all of the neurons that are ultimately going to be sending messages of we saw some light are going to travel through that optic nerve. Let's go figure out what's going to happen in the optic nerve. No, in the brain. Let's go find out how we're going to get the information to your brain.